Hey 7th graders, if you're watching this video, you are either at home doing this assignment or you guys are in class, but I am gone. With that being said, today we're going to do 3.2 and 3.3. And your learning targets for today, I can explain how energy is used to help amino acids build proteins, which are used in cellular growth and repair. So we learned a little bit in our last couple lessons about metabolism and how we use glucose and oxygen to produce energy in the body. Today we're going to go a little bit further to see how glucose and oxygen come together to form energy, how energy helps us with our growth and repair in our cells, and how amino acids factor into that as well. So that's really going to be our focus, is just a little bit beyond cell respiration today. Okay, with that being said, I'll go ahead and explain your warm-up. You guys should have already done this as your bell ringer as you come in. And again, if I'm not here today and you guys have a guest teacher, as I go through each of these activities, you can pause and give time for each activity to be finished. But as the kids did this as their bell ringer, I'm just going to go ahead and talk really quick about what you guys should have done. Okay, so first thing you guys should have done when you guys came in the door today is your bell ringer. You have key concept 9 and 10 to add to the key concepts page of your metabolism section of your notebook. Key concept number 9, inside the cell, the atoms that make up glucose and oxygen can be rearranged to make different molecules. This chemical reaction is called cellular respiration and releases energy. So when you guys go for a run, maybe you guys eat a banana and obviously you're drinking water, breathing air as you guys work out. Okay, as you guys go through all of that, you guys are taking all that stuff in the body, all the glucose from the banana, all the oxygen from your breathing, you're sending it to your cells, and your cells are rearranging all the little atoms that make those up, and in that process, you're creating energy, which we need to keep running, which you guys saw that in the sim in the last lesson where you guys made the little guy run without any air and saw how long he could run for, same with glucose. Okay, so that's where our energy comes from, is this process called cellular respiration, okay, which is kind of the foundation for metabolism. And finally, cells can grow and repair themselves by combining amino acid molecules to form larger protein molecules. So early in one of our lessons, we talked about why we would see proteins in our cells. Okay, this is where we're kind of tying that in now. Up until this point, you guys have looked and been like, all right, starch is too big to fit into our bloodstream and into our cells, so we shouldn't see it in the cells. And I know a lot of you guys felt the same way about proteins, but this is going to explain why we'll see proteins in our cells. Okay, yes, they can't fit into our bloodstream and then come into our cells, but we do rebuild them in our cells to form proteins. Okay, so cells can grow and repair themselves by combining amino acid molecules to form larger protein molecules. This growth and repair requires energy. We can't make these proteins out of the amino acids in our cells unless we have energy. So we get that from cell respiration, which we just talked about in key concept number 9. Okay, that being said, you guys should have also done your warm-up on slide 3. So if a patient has a medical condition that causes his cells to absorb fewer than normal blank, you guys would use the draw tool to circle your answer, molecules, this patient would likely feel very tired. So circle the one thing that we would see less of in his cells that would cause him to feel tired, and explain your reasoning. All right, with that being said, at this point, everyone should have their computer facing forward as I go on and explain activity 3 to you guys. So make sure your guys' computers are facing forward. Okay? All right, so your next activity today is a little hands-on activity, and your guest teacher for today should have prepared this for you guys. What you guys will get is you guys should have grabbed a pair of goggles on your way into class this morning with your bell ringer. You guys will also receive a tray that has a little baggie on it. I know it's kind of hard to see. Half of the baggie, it's kind of all mixed up at this point, but you guys should see these little white pebbles in there. They're very small, but you guys should also see a white powder. The pebbles are called calcium chloride. This is very similar to the same stuff that you guys would put on your sidewalk if it's icy. And the white powder is baking soda, so you guys probably use that a lot. You guys also have a little Dixie cup that has 10 milliliters of this chemical called phenyl red in it. Phenyl red is a pH indicator, so it tells us if something is acidic or basic. As you guys see it right now, it's red, but you guys are going to see a change in that. So let's just go over some safety. Okay, you guys are using chemicals, so the whole time you're doing activity 3, you should have your goggles on. Basically, I'm asking that you guys use common sense with this stuff. So do not touch or taste or smell any of these things. Okay, we're going to be doing this. It's all going to be enclosed in a bag, and it will stay that way. Okay, so once you guys pour your chemicals into this bag, you will not open it back up again. Okay, do not, if you guys get any of this on your hand for whatever reason, make sure you guys wash your hands. Again, your safety goggles stay on the whole time. Okay, and finally, here's your guys' instructions for this. So you already have the 10 milliliters of phenyl red measured out for you guys. So what you guys will do is you'll open the bag with your 2 powders. You guys will slowly dump in your phenyl red, and then you guys will try to squeeze as much of the air out as you can without making a mess, and then seal up your Ziploc baggie. And then you guys will observe what happens. Make sure you and your partner both get a chance to kind of see it and touch it. You guys can touch it from outside the bag and see what's happening. And then you guys will make observations. So let's go ahead and go on to the next slide. So on this, if you guys are absent, you guys obviously won't be able to do this. You guys will watch this video right here, and I'll show you what happens with this. Okay, once you guys are done, you guys will answer what were your observations, list all that you guys can observe with that, and then you guys, without opening your baggie, can throw your baggie directly in to the garbage and put your goggles up once your stuff is thrown away. Okay, so go ahead, the guest teacher, you can go ahead and pause this video right now and let the kids complete activity 3. So go ahead and turn your computers around and pause this video. All right, so for the next part, you guys are going to do activity 4. Okay, if you guys are at home or if you guys are in class, you guys can do this either way. Go ahead and open this link up. It's going to take you guys into the Amplify library. Okay, you guys will be reading this, but those of you guys sitting in class right now, I'm just going to go ahead and let the guest teacher open this link up for you guys and pull it up on the main screen, and then you guys can just listen to this first article. There's 2 articles you guys are going to read today, so I'm going to have you guys just listen to the first article, and then the second one you guys will read on your own. So again, I'll have the guest teacher go ahead, right-click, open this link up, pull it up in the library. You can hit play right here, and then hit play.
Cellular respiration.
Adjust the volume as needed, and everyone please make sure your computer's facing forward and listen to this article being read for you. So go ahead, face your computers forward, pause this video right now, and let's listen to cellular respiration. All right, moving on to the sim. Today you guys are going to take a look at what cellular respiration looks like in the sim. So here is your link right here to your simulation. So you go ahead and right click and open that link up, and it's going to take you guys into, again, the simulation here. You guys will choose that you're not on an iPad, unless of course you're on an iPad at home. Okay, what you guys are going to look at is going to healthy body, selecting observe, and then feed the body as much. So give it a little bit of everything, maybe 2 corns, 2 Sammies, make sure it has enough food, and 2 fish. You guys are going to slow your simulation down to 0.5, and then you guys are going to zoom in to the cell, which is the yellow box in the right-hand corner. So when you guys do that, I want you guys to notice, what do you notice about energy release in the cells? Okay, so again, I'm going to go healthy body, reload healthy body, yes, and I'm going to hit observe. I'm going to slow this down to 0.5, and then I'm going to feed it enough of everything. So there's some fish, there's some corn, there's some Sammies. I guess apparently that's all he can eat. And then you guys will go click on this and zoom in with the magnifying glass. And you guys should be able to get some of these molecules into your cells. And again, what you guys are looking for is energy production here. Okay, so here's some oxygen coming in. Okay, we should see some glucose coming in soon. And again, I want you guys to kind of look at, all right, oxygen and glucose combine to produce energy in our little mitochondria here. So when we get some glucose in here, you guys are going to see that happening. I want you guys to pay attention to the energy portion of this. Okay, so I'm going to go ahead and pause this so it's not a surprise for you guys. And you can go ahead, pause this video, turn your guys' computers around, and I want you guys to complete slide 8 and slide 8 only. Okay, once you guys are done with slide 8, turn your computers back towards the front. All right, so you guys should have just completed slide 8, and what you guys observed in there is when glucose molecules joined our oxygen molecules in the cell, okay, One thing that we saw come out of those little mitochondria, these little guys right here, was water. So water, these little, what color are they? These little like trapezoid, aqua looking blue trapezoid should have come out of the mitochondria, as well as carbon dioxide. Okay, so we should have seen that. And then you guys should also see production of energy with that as well. Okay, so I want you guys to think about that. So this is actually, if you guys know anything about photosynthesis, and we're going to learn a little bit about photosynthesis later, this is actually the reverse equation to what happens with photosynthesis. So if you guys look at how a plant gets its food, it takes energy from the sun, takes carbon dioxide from the air, and it takes water from the ground, and it rearranges all of those to form oxygen, which it gives off for us to breathe, and it makes glucose, which the plant then can use as food to do cellular respiration as well. So then it takes the glucose, and it also uses oxygen to break it down into water. So plants actually do photosynthesis, which is the reverse of this, as well as photosynthesis, or excuse me, as well as cell respiration. So they actually do both processes. They do photosynthesis to make the glucose, and then they still have to use that glucose for energy, so they also do cell respiration to turn that glucose back into energy that they can use, not energy from the sun. Okay, anyway, we'll get into that later in the year, but I just wanted to kind of talk about that for a second. All right, your guys' again, computers should be facing me. Your next activity is activity 6. The sub is going to pull this up for you guys and play this video. So right click. If you guys are home, you guys are obviously going to watch it on your own. And you guys are going to watch this little video here, which is called The Story of Sanctorius. So it's kind of one of those first old scientist dudes, and how he thought of the food we eat. Like, it doesn't make sense. The food we eat goes into our body, it weighs a certain amount, but when it comes out, it doesn't have the same mass. So why is that? Okay, so he really did a lot of gross scientific work, which you guys are going to learn about. So with that being said, go ahead, pause this video, and you guys can play this video for everyone on the big screen. All right, so after you watch that video, you need to answer this question on slide 10. Because of her diabetes, Elisa has lower numbers of glucose molecules getting to her cells. Why did this cause her to feel so tired? So everyone take a second, flip your computers back around. I want you guys to answer this question on slide 10. When you have it answered, I want you guys to face your computers back forward. And go ahead and pause this video. All right, your final part of today's assignment is your homework. If you guys don't finish this in class, this is homework for you guys. It's due tomorrow, so make sure you guys get it done for tomorrow. You guys have another really short article to read. It's called Growth and Repair. So this is kind of where we tie in, all right, you just made energy and cell respiration using glucose and oxygen. What do we use that energy for? Obviously, we use it to move our bodies. But when we talk about growth and repair in the muscles, what does that look like? Okay, or anywhere in our body that has some kind of growth or repair to do. Okay, so let's take a look at what we use for growth and repair and how energy ties into that. So you guys will right click and open this link right here, and it's going to take you into this really short article on growth and repair. It's about 3 paragraphs long. You guys will read this on your own. So if you have your own earbuds, you may not borrow mine today. You guys can use those, if not, to listen to the article. If not, you guys can just read it on your own. So read this short little article on growth and repair, and then answer these 2 questions. How were amino acid molecules used in cellular growth and repair? So remember, we eat proteins, we digest the protein into amino acids, and then those go into our bloodstream and into our cells, and here we use them for growth and repair. So what do we use them for? Okay, what do they do once they get to our cells? And then how are glucose and oxygen molecules used in cellular growth and repair? So why are they important? I mean, obviously we need amino acids for growth and repair, but why do we need glucose and oxygen for growth and repair as well? So talk about that. And again, both of those come from the article. Okay, so check back to your article if you need help. Okay, that's the first part of your homework today. The second part of your guys' homework is a little look at growth and repair in the simulation. So again, you guys will open up the simulation. Are you using an iPad? No. Here's your guys' instructions for this. You guys are going to healthy body and then observe. You're going to feed the body 3 Sammies. And then you're going to zoom in to see what is happening inside the cell by pressing on the yellow box and then pressing on the magnifying glass, and then observe closely and answer the questions. So you guys might want to slow it down like you did on the last part of the sim as well. What did you notice happening with the amino acid molecules in the cell? So answer that there. Okay, again, you guys are going to see that in this sim. What are the amino acids in this little part of the cell doing? Okay, once they have been in there for a little bit. And then how does energy help with this process? So talk about that formulation of glucose and oxygen, how it's used to make energy, and how energy helps out with this process of what happens to our amino acids. And then finally, use your draw tool right here. In the cell, amino acid molecules combine to form, circle the correct answer there. Okay, that's it for your guys' homework. If you guys don't get that done, make sure you guys finish it up before you, finish it up at home. Then do your wrap up and hand it in. You guys can now flip your computers back around, finish up your homework. I hope you have a great day. I'll talk to you soon. Bye.